The rectangular coordinate system, also called the Cartesian coordinate system, consists of two number lines that form a plane. The horizontal number line is called the x-axis. The vertical number line is called the y-axis. There's a point where these two axes intersect. That point is called the origin. The two number lines separate the plane into four regions. The first region in the upper right-hand corner is called the first quadrant. The second region is the second quadrant, going counterclockwise. The third region, the third quadrant, and the fourth region is called the fourth quadrant. In order to plot a point in the rectangular coordinate system, it requires two numbers. One number called the x-coordinate tells you how far from the origin to go along the x-axis. The second number, called the y-coordinate, tells you how far to go from that place along the y-axis. Once you've found that position in the plane, you can plot that ordered pair as a point. So every ordered pair in the plane corresponds to two numbers. So let's plot this ordered pair in the plane. Here we have a rectangular coordinate system consisting of a horizontal number line and a vertical number line. And the ordered pair that we want to plot is negative 4, 2. So from the origin, we're going to go 4 units in the negative x direction. Well, on the x-axis, negative is to the left, so I'm going to go 4 units to the left. And from there, I'm going to go 2 units in the positive y direction, which is 2 units up. There I'm going to plot an ordered pair. So this is the ordered pair, negative 4, 2 when you plot it, all right? This ordered pair is in the second quadrant. Let's plot another ordered pair. So the ordered pair is 0, negative 3. So the 0 means from the origin, I'm going to go 0 units along the x-axis. So I'm not going to move 0 units along the x-axis. But then from there, I'm going to go negative 3 units along the y-axis. So that's negative 3 units in the y direction. I'm going to be here, and that's where I'm going to plot my ordered pair. So this would be the ordered pair 0, negative 3. That ordered pair 0, negative 3 is not in any quadrant. That ordered pair is on the y-axis. That means that that ordered pair would be the y-intercept of this graph. Y-intercept is any point that is on the y-axis. Let's talk about equations of lines in the rectangular coordinate system. Given real numbers a, b, and c, and a and b are not both 0, the standard form of a linear equation in two variables is ax plus by equals c, is the standard form of a linear equation in two variables. So let's take a look at a linear equation and an ordered pair. Let's try to figure out if this ordered pair is a solution to this linear equation. Because the x value or the x coordinate of this ordered pair is 8, I'm going to let x equals 8 in the original equation here. So if this is a solution, this ordered pair, I would expect the y value to be negative 1. So I replace x in the equation with 8. 9 times 8 gives me 72. I'm going to solve for y by subtracting 72 from both sides. Once I subtract 72 from both sides, I get 8y is equal to negative 8. 64 minus 72 is negative 8. And then I divide both sides by negative 8. And that means that y is negative 1. So because I plugged in x equals 8 as the x value, and the y value turned out to be negative 1, yes, this ordered pair is one of the solutions of this equation. Let's try this one. Let's see. So is the point 0, 5 a solution of the equation? So once again, we're doing the same thing. We're going to plug in 0 and see if we get 5 as the result. So let x equal 0 and solve for y. We should get 5 if this ordered pair is a solution. So I plug in 0 for x. 9 times 0 is 0. 0 plus 8y is just 8y. And then I can divide both sides by 8. And then I get y is equal to 64 over 8, which means that y is equal to 8. So I plugged in 0 for x and I didn't get 5 for y. I got 8 for y. So 0, 5 is not a solution to this equation. A solution to this equation where x is 0 would be 0, 8. Here I have two ordered pairs that I started with. I had the ordered pair 8 and negative 1. Remember, we plugged in 8 for x and we got negative 1 for y. And I also have the ordered pair 0, 8. Remember, 0, 5 was not a solution. When I plugged in 0 for x, we got 8 for y. Now what I'm going to do is I'm going to go ahead and I'm going to complete this ordered pair by plugging in 0 for y into the same equation and solving for x to figure out what value would go here. Plugging 0 in for y and solving for x, that's 9 times x plus 8 times 0 equals 64. I'm just replacing y with 0 like this table tells me to do. 8 times 0 is 0. 9x plus 0 is just 9x. So 9x equals 64. And I divide both sides by 9. 9 divided by 9 cancels. 64 divided by 9 is the value of x. So I get x is equal to 64 over 9. And I put it into the table. So now we're going to go ahead and we're going to take this table and we're going to graph this linear equation in two variables. So I'm going to plot this ordered pair 8, negative 1 because it's easy. And I'm going to plot this one 0, 8 because it's easy. Let's just plot those two that are easy. The 8, negative 1 is here and the 0, 8 is here. And this one is like 7 and change 0. So that's right around here somewhere. A little bit more than 7 on the x-axis because the y value is 0. We're just going to connect these 2 points that we have here, and that will be the graph of the line. So the equation 9x plus 8y equals 64. If you complete the table of ordered pairs and plot any two ordered pairs, when you connect those two dots, you will have graphed that line. There's two special cases for lines that I want to talk about. One of the special cases is a vertical line. The equation of a vertical line doesn't have all the terms that this equation has. The equation of a vertical line looks like this. The equation of a vertical line with x-intercept a0 is x equals a. That's the equation of a vertical line. That's what the equation would look like if you try to put it in standard form. Now, this is a straight up and down vertical line, and it goes through the x-axis at the point a0. So it goes through the x-axis at the point a0. Let's graph this vertical line. I know it's a vertical line because it fits the formula. It says the equation of a vertical line is x equals a. In this case, a is negative 4, which means that the x-intercept is a0 or negative 4, 0. So I'm going to plot that point, negative 4, 0, and I'm going to make a vertical line going through negative 4, 0. And that's the graph of the vertical line. If you recognize the equation as the equation of a vertical line, then you can graph the vertical line by plotting any point that has negative 4 as its x value, because every point on this vertical line has an x value of negative 4. And then you just draw a vertical line. The other special case that we want to talk about is the case of a horizontal line. So the equation of a horizontal line that has y-intercept 0b is y equals b. So you see it's a horizontal line like the horizon, and then there's an ordered pair on the y-axis, 0b, and that is called the y-intercept. It's just a horizontal line through every point that has a y value of b. So let's take a look at this horizontal line. I recognize it as a horizontal line because it fits the form. The equation of a horizontal line that goes through 0b is y equals b. This is y equals 2, which means b is 2. The y-intercept that they're talking about is the point 0, 2. 0, 2 is the y-intercept, so let's plot it. There's 0, 2, and then I just make a horizontal line going through 0, 2. And there's my horizontal line. So now let's draw a line that's neither horizontal nor vertical. And just like we did before, we're going to use the intercept. The x-intercept is the point A0 where y is equal to 0. That's the x-intercept, the point where the graph crosses the x-axis. The y-intercept is the point 0b where the graph intersects the y-axis. So here's the equation of a line. This isn't the equation in standard form. This is actually a different form of a line called slope-intercept form. But right now, they just want us to graph this equation, and this is the equation of a line. So let's go ahead and find the x and y intercepts. So first, let's find the y-intercept. To find the y-intercept, we'll let x equal 0. So in this equation, we're going to replace x with 0. So instead of x, we're going to put a 0 in. 2 over 3 times 0 is 0. 0 minus 4 is negative 4. And then that means if x is equal to 0, y is equal to negative 4. So I get the ordered pair where x is 0 and y is negative 4. 0, negative 4. That's this ordered pair on the graph right here. 0, negative 4. So let's do the same thing and find the x-intercept. So we're going to let y equal 0 now. Instead of letting x equal 0 like we did before, we put a 0 in for x. Now we're going to put a 0 in for y. So we replace y in this equation with 0, and we get this. Now we're going to solve for x. We're going to add 4 to both sides to get rid of the minus 4. We add 4 to both sides. We get 0 plus 4 is 4, and then the 4 and the negative 4 cancel on the right side. So I just get 2/3 x. Then to get rid of multiplication by 2 and division by 3, I'm going to divide by 2 and multiply by 3. So I have the fraction where I divide by 2 and multiply by 3 instead of multiply by 2 and divide by 3. So to get rid of this 2 over 3, I just multiply both sides by 3 over 2. 3 times 4 gives me 12 over 2. So 12 over 2 is equal to 3 times 2 is 6 over 2 times 3 is 6. 6 over 6. 12 over 2 is 6. And 6 over 6 is 1, so this equals 6 equals x. This means that 6 is equal to x. So I now get the ordered pair where y is equal to 0, y is equal to 0, and x is equal to 6. That's this ordered pair, 6, 0, over here. Once again, in order to graph a linear equation, if it's not a horizontal or vertical line, all you need is 2 points, 2 points. Once you graph those 2 points, you connect those 2 points with a straight line. And that is the graph of your linear equation.